So in this lesson, we're going to start to look at the graphs of exponential functions and also their inverses. And we're actually going to start there and talk about finding the inverse of an exponential function. So first off, the parent exponential function is in the form y equals b to the x, where the base has to be bigger than 0 and the base can't be 1. So if I had a function like this, it would kind of jump all over the place because negative numbers when raised to even exponents are positive and negative or odd exponents are negative. So we can't do that. And this function would just be a straight horizontal line, so also doesn't count as an exponential function. But any other positive number we can use for that base. Unlike other types of functions where there is only one parent function, there are many exponential parent functions because the base can be any number as long as it is greater than 0 and not equal to 1. So this would be considered a parent exponential function. This would be a parent exponential function. This would be a parent exponential function. If it's just a number to the x, a b to the x, then that is a parent exponential function. So we're going to do the general y equals b to the x for the inverse. So the b could be any number. From here, we're finding the inverse, right? Just like any other inverse problem, we switch x and y. Now, the issue comes in with solving for y. Because right now, like I can't make the x and the b have the same base. If I raised it to the 1 over y exponent, that's just going to move the exponent over. So we actually need something brand new for what you guys are learning about math, and we need a different way to write this. And the thing that allows us to write this in a different way is something called a logarithm. So I'm actually going to write this with the b to the y first. Okay, so I haven't changed anything. I haven't moved anything around. I've just basically switched the two sides, but it's still the same equation. So a normal exponential equation is in this form. Base to an exponent equals a number. So in this case, I'm going to take this and write it down underneath. Base to an exponent equals a number. When we put this word log or a log function on the equation, it's like we're remixing it and writing it in a new way. So when I write this, it's almost like, hey, we're writing stuff differently. Okay, that's what the log is telling me. It means other stuff too, but for now, let's move the numbers around. So the base, which is right here, we actually write down low, kind of like it's a subscript. The number it's equal to, which in this case is the x, goes next to it. And it's actually on the same line. So this log and the number is not high like an exponent. Those are on the same level, just the base is low. And then the exponent, right, which in this case is the y, right, that's where we put the exponent, actually becomes the answer, okay? So remember, our goal was to get y by itself, and writing it in this new logarithmic form moves stuff around so we can actually have a y equals. So this new equation, I'm going to write the y first, log base b of x. And then this is the inverse, and we'll be graphing that soon. So we're going to do the same thing with y equals 2 to the x. And if I know it took me a long time to explain it, but it really is not that many steps. So because I covered this up, I'm just going to write it over here. So we're finding the inverse. So the first thing we do, find the inverse, is switch x and y. Okay. And then we're going to write this in log form. So looking at our rules, we write the word log. Whatever the base is, right, we write down low. So the base here is 2. Whatever the answer is, right, or the number on the other side, we put it next to it. So we're going to write the number on the other side as x. And then the exponent becomes the answer, which you'll hear me say a bunch, okay? So the logarithm just takes those numbers and puts them in a different spot. So now we're actually going to look at the graphs, and we'll do this on Delta Math. Or not Delta Math, Desmos. So I have my graph 2 to the x, and then my inverse, y equals, just recopying this, log base 2 of x. So first we'll graph 2 to the x. Okay, so here's our graph. This should look familiar from 9th grade. If I went to a table, we're just going to copy these values. Now, I know it says 0.25 and 0.5. I'm actually going to write those as fractions. You can write them either way because we'll just talk about what the exponents mean. But I'm going to go back and fill out this table. Now, I'm just going to go -2 to 2, so I actually have an extra cell in here. 1, 0, 1, 2. And these should make sense because 2 to the 0 equals 1. Anything to the 0 is 1. 2 to the first is 2. 2 to the second power is 4. Okay. Working backwards, 2 to the -1 is 1/2, right? That means divide, or 0.5. So we could write 1/2, or we could write 0.5 here. They're both the same thing. And then up here, 2 to the -2 is 1/4, 1/2 squared, which is also 0.25. So thinking about it mathematically, this kind of shows a nice pattern, but ultimately on a graph, decimals are a little easier to graph than fractions. So for the log base 2 of x, I'm actually, because that's the inverse, just going to switch those values, but I will show you, you do get a different table if you type that in the Desmos calculator. So I'm just taking all of my y's and writing them as x's, 1/4, 1/2, 1, 2, and 4. And all my x's are becoming the y's because this is the inverse. Okay. So we're going to graph this out, see what these two graphs look like. I'm going to do my 2 to the x in green. Okay. So I'm going to start here, 0, 1, 1, 2, 2, 4, and if I kept going 2 to the third is 8, so that would go up in that direction just to kind of get the shape. And then the other way we have 0.5 and 0.25, and we'll talk more about this on the next page, but basically this graph comes down and doesn't actually cross or touch the x-axis, even though it kind of looks like it does. So this is 2 to the x. So if I graph log base 2 of x, I'm going to do that one in red. Okay, so here, 0, 1, or 1, 0, sorry about that. So 1, 0, 2, 1, 4, 2. Okay, and these ones are in here like this. So this is my y equals log base 2 of x graph. And that's what exponential and logarithmic graphs look like. One quick check, since these are inverses, if I was going to draw in that line y equals x, right, it does look like it's a reflection over y equals x. If you remember that from when we first learned inverses, it should always work out that way if I graph the function in its inverse. So now we're going to go on Desmos. Now, when I graph log base 2 of x, let's get this one back. I'll write this down in the notes, but in order to get that low number, you have to press shift and then the minus sign, which is next to 0. So it's shift, minus, or underscore, and that's going to bring it down low, and you can type in your 2 and then your x. So here we see that green graph show up. Now, if I was going to do a table for this one, okay, we actually see, interestingly, at -2, the graph is undefined, and that's because there's no values over here, right? This green line doesn't come over into the fourth quadrant over here. -1 is undefined. 0 is actually undefined as well. And then here, actually, just when we pass 0, so 0.00001, right? I can't, the smallest number right next to 0 starts to have values over here. And then we see those points 1, 0, 2, 1. If I click here, and we'll put it in the table. If I put a 4 here, right, 4, 2, The next one would be 8, 3 following those powers, okay? But here is the log graph. And remember, the new thing to get this subscript or the base, you press Shift minus on a keyboard. Okay, so those are your basic graphs. We're going to write down properties of those graphs now. And I'm going to do that on this page. I'm actually going to start a new video, though, because I don't want these to get too long.